In the early 90s, an expedition team climbed up onto the plateau of Amsterdam Island and ran into something that should not have existed there: a huge herd of cattle. Thousands of animals were calmly grazing in the middle of the ocean, hundreds of miles from the nearest inhabited land. But how did they even end up here? And why did they ultimately wipe out every last one of these cows? Subscribe to the channel. It gets interesting from here. Amsterdam is part of the French southern and Antarctic lands. The island covers about 55 square kilometers. Basically, it is the top of a volcano rising to nearly 900 meters. The shores are mostly rocky, landing is difficult, and the weather can change abruptly. The climate here is not Arctic, but it is exhausting. Temperatures usually stay between 5 and 15 degrees. The wind can be strong, and the humidity is almost constant. Low clouds and fog often close off the plateau, and sometimes the rain falls for days without a break. Before people showed up, only birds and marine animals lived on the island. Elephant seals lie along the coast. There are plenty of seals nearby, and albatrosses and petrels circle above the water. There were no land mammals, so plants and soils developed without the pressure of hooves and without year-round grazing. Europeans noticed the island in the 17th century, when Dutch sailors were looking for reference points in empty ocean latitudes. The name stuck from the ship Amsterdam. That was the vessel that discovered this patch of land. For a long time, visits were rare, mostly by hunters and sealers, and the island lived by the rules of wind and surf. In 1892, France declared Amsterdam Island and the neighboring St. Paul Island its territory. Later, these lands were tied to Madagascar and then formalized as the separate French southern and Antarctic lands. In the 19th century, southern sea routes became noticeably busier. Sealing vessels hunted seals, and merchant ships ran to Australia and back. Any point where you could take on water and get fresh food was considered lucky. In that context, the idea of setting up a place with a reserve of livestock seemed completely logical. The nearest large populated island under French administration was the colony of Réunion. From there came people and ships that might decide to attempt a landing on Amsterdam's difficult coast. A farmer named Ertin came up with the idea to try to create a small settlement on the island and establish a working farm. On the 18th of January, 1871, Ertin's group landed on Amsterdam. They tried raising sheep and cattle, growing vegetables, and building housing. However, after 7 months, it became clear supplies were shrinking, things were not working out, and on the 19th of August, the people left the island, abandoning all the animals there. That is how only 5 cows remained on Amsterdam. Not an experiment, not a scientific program, just ordinary abandoned livestock. Back then, nobody talked about genetics, ecology, or possible consequences. It all seemed simple. The animals would either die or survive until some random future landing. The first years were decisive. The cows found wet meadows in the lowlands and stayed where grass was available almost all year. There are no wolves on the island and no big cats, so adults more often died from falling off cliffs and from exhaustion, not from predators. Isolation worked in their favor. Many common livestock diseases never made it to Amsterdam because ships came here rarely. When there are no epidemics and there is feed, a population grows even from a small start.
That is why 5 animals were able to produce a stable herd, enough to keep the line going.
Gradually, the domestic calmness disappeared. The herd began to stay tighter together and look for shelter from the wind in hollows and folds of the terrain. Calves that handled the slopes better survived more often. So behavior changed not through training, but through simple selection. By the start of the 20th century, sailors were already writing that they saw not lone cows, but small groups. That is an important sign. It means reproduction had been going on for decades. But nobody kept exact counts. The island remained a distant point with no permanent observers and no owner control. After World War II, France established itself on the island for science and weather monitoring. In 1949, a base was opened there. At first, it was called Camp Hertin. Later, the Martin de Vivier station appeared. Usually a few dozen people worked there, and they were the ones who began seeing the herd regularly. The station was named after the leader of the first overwintering team. He spent the cold months on the island with a few dozen colleagues. For a place like this that is a real feat, everything here depends on the sea and the weather. Even now, about 30 people live on the island, and any emergency quickly turns into isolation. With the base came routine record-keeping. People walked routes, noted groups, tracks, and grazing areas. It turned out the cows had taken over a significant share of the lowlands, and there were a lot of them. Estimates by the end of the 80s put the number at about 2,000 head. 2,000 head on an island of roughly 55 square kilometers is a load like a solid mainland pasture. The grass couldn't recover on the same patches, and over time, more and more trampled clearings appeared. The soil suffered the most. On a volcanic island, the fertile layer is thin. Hooves tear up the sod. Water runs along the grooves, and after heavy rains, gullies form. Where there was grass yesterday, by the next season, there can be only rock and loose clay. The second problem was the small phylica trees. This is a local species that forms the island's only real forest. The cows ate young shoots and broke branches. Old trees still held on, but new growth almost never appeared, which meant the forest was slowly being left without a future. Along with the forest, life under the canopy grew poorer. Less foliage, less shelter, fewer insects. For an island ecosystem, those chains are especially painful because there are almost no backup habitats. Scientists increasingly noted that the changes were not isolated. They were spreading across the entire feeding belt. There was a third line, too, the impact on birds. Large seabirds nest on Amsterdam, and later the Amsterdam albatross was described here. This species breeds only on one island, and any degradation of slopes near nesting sites raises the risk for a rare population. When the species was first described in 1983, only 5 breeding pairs were known. Biologists looked at the island and understood that every loss of nesting ground is a blow that cannot be made up by neighboring colonies. The cows did not hunt birds, but they changed the environment itself. They shortened the grass, compacted the soil, and sped up runoff. On open plateaus, the wind turns harsher when the sod disappears. As a result, nests become more vulnerable, especially in bad seasons. In scientific reports, the herd was more and more often called the mainland-based factor of degradation. At the same time, the cows had an everyday role. The station needed food, Shipping everything in was too expensive, and some meat was taken locally. Every year, dozens of males were shot, but the population still held. By the middle of the 80s, it was clear that selective culling was not enough. So they decided to physically separate the cows from recovery zones. In 1987, an electric fence about 4 kilometers long was installed across the island. The fence split the island into a south, where they planned to restore vegetation, and a north, where the herd was left. After just a few seasons on the southern side, it became noticeable how bare areas were filling back in. Mosses and grasses returned, and young shoots appeared on phylica trees. But in the north, a crowding effect appeared. The cows were stuck on a smaller area, pressure increased, and degradation continued. This was the key moment. It showed that without reducing numbers, the fence only moves the problem. It does not solve it. So in 1988, they carried out a major reduction. South of the fence, they killed 1,050 animals. After that, the cows were finally confined to the northern sector. After that, a long phase of control began. In the north, there were about a few hundred head left, and the station kept taking meat, shooting about 50 males per year. The numbers declined, but ecological damage in the herd zone remained. In parallel, measurements continued. They compared plots on both sides of the fence, the share of bare soil, the speed of regrowth, and the appearance of young trees. For Amsterdam Island, such contrasts are rare, and the data were very clear. Where there are no cows, recovery happens. Where there are cows, it slows down. In the early 2000s, genetics was added to the story. The population came from 5 cows, a rare example of the founder effect in a large animal. Scientists found signs of isolation and discussed whether a distinct line had formed. But this mattered less and less for conservation decisions. By that time, the island was suffering not only because of cows. Amsterdam had rats and feral cats. They harmed birds. There were also introduced plants, but it was the cows that were destroying soil and stopping the forest from recovering. So the question came down to them. In 2007, they evaluated recovery in the southern areas and reached a harsh conclusion. Where there is no grazing, plants return. That means if you remove cows completely, the island can recover noticeably faster. After that, a course toward full eradication became official. The decision was unpopular with some people who had worked on the island in earlier years. They saw the herd as part of the station's history, but conservation arguments outweighed that because Amsterdam is valuable for unique species and very slow soil recovery. In 2008, the final stage began, a complete cull of the remaining cows in the northern sector. The work dragged on because of logistics and weather. The island is hard to reach, and resupply is rare. Still, the program was carried through to the end. In 2010, there were no cows left on Amsterdam. That ended a story that had stretched for almost 140 years. It started as a private settlement attempt and ended as an ecological operation on a remote territory under strict government control. After the herd was eliminated, scientists increased monitoring. They were interested in 3 things: the rate of regrowth on bare slopes, forest recovery, and the condition of birds. On an island, every centimeter of soil matters, so even small improvements were tracked year by year. The Amsterdam albatross became a symbol of vulnerability. Its nesting area is very small, and the population has been counted continuously since the 80s. The number of breeding pairs grew from 5 at the start of observations to a couple dozen and more by the 2000s, and they linked that to habitat protection. At the same time, recovery is never instant. Where soil was washed away, grass will not return in a single season. First mosses take hold, then grasses, and only later do complex communities return. Scientists wrote plainly that some of the damage will be visible for decades. This story has another layer too: climate observations. The island has instruments that track air composition and winds in the southern latitudes. There are few points like this, so the island matters to global science. That is another reason they try to protect its condition. In 2025, it became obvious again. A major fire broke out on the island, and the entire station staff was evacuated by ship. Flames covered most of the territory, and infrastructure was damaged by fire and smoke. For an island like this, it is a blow that will take a long time to heal. If you put it all together, you get a strict chain. The landing of 5 cows, population growth, soil degradation, the fence, mass reduction, and the final eradication. There is no mysticism here. There is island math, little land, slow recovery, and heavy hooves. The scientists who lived on the island, of course, were against the killing, but they could not change anything. They were shocked. First, because of the scale, just 5 animals produced offspring in the thousands. Second, because of the consequences. The herd changed the island more than many storms. And third, because of the decision. They had to kill every last descendant, even though they were a living example of natural selection. The story of Amsterdam Island often sounds like a survival legend, but it is more accurate to treat it as a warning. On islands, any invasive population grows fast, and stopping it is hard. One season's mistake can drag on for a century and demand harsh measures. Ertin himself probably could not imagine that his settlement attempt on an uninhabited island would turn into a tragedy like this. He was thinking about meat, supplies, the survival of his group. But islands do not forgive even rational decisions if they break the balance, especially where nature builds an ecosystem very slowly. That is exactly why modern rules for remote territories are so strict. Any import of animals and plants is checked, and access is restricted. Amsterdam Island became an example ecologists cite when they explain why you cannot leave animals unmanaged, even on an uninhabited patch of land. Amsterdam's story is simple in chronology, but ruthless in the outcome. 5 abandoned cows multiplied into the thousands, wrecking the ecosystem, and in the end, became the victims of total eradication to save a unique island. Was it the right call? What do you think? Was it worth killing thousands of animals, or was there another path? Make sure to write about it in the comments.